Here are two interesting ways of representing the golden ratio phi. We have the continued fraction here, 1 plus 1 over, 1 plus 1 over, and so on. And we have the continued square root, or these nested radicals of square root of 1 plus the square root of 1 plus the square root of 1, and so on and so forth. Actually, as a quick aside, how do y'all pronounce this constant, phi or phi? I personally switch between the pronunciations depending on how I feel like that day, but I think today is a phi day. But if you're a bit rusty on what the golden ratio is, recall that its exact value is 1 plus root 5 over 2, or you can actually obtain it by looking at this rectangle, this golden rectangle. Notice how the ratio of a plus b over a is equal to the ratio of a over b. In other words, what we're saying here is that the largest rectangle is similar to the smallest one. Now, that ratio of a over b is what we call the golden ratio, phi. So actually, if we rewrite that equation in terms of phi, we get 1 plus 1 over phi equals phi. Multiplying through by phi, we get phi plus 1 equals phi squared. And solving this quadratic for phi, we get 1 plus root 5 over 2, or 1 minus root 5 over 2. We, of course, take the positive root here, but the negative root actually represents the negative reciprocal of phi, negative 1 over phi, which actually has some nice properties or connections with the original golden ratio phi. Now, if we look back at our two other ways of representing phi, we can actually show that each of these two representations actually equals to phi by just setting each one equal to, let's say, x. And we're going to show that x is essentially phi. So for the continued fraction, notice we can actually replace part of its expression with x, because the continued fraction has a fractal-like structure to it. It's self-similar. So in other words, we can actually allow this portion of the continued fraction to be x, and now we get 1 plus 1 over x equals x. But that is precisely this step in our original derivation for the value of phi. So we're just going to get x equals to phi here, the positive root for phi. Likewise, for the continued square root, we can replace this portion of the expression with x, giving us the square root of 1 plus x equals x. Squaring both sides, we get 1 plus x equals x squared, but that is precisely this step in our original derivation for phi. So x here is also 1 plus root 5 over 2. I just think those are two very cool ways of representing phi, or phi, whichever. But in any case, I hope you're doing well. Make sure to hit that follow button for more math content and to make your algorithm better, especially with all the brain rot that's currently running around because of Sora 2. So maybe this will heal your algorithm a bit. All right, as always, I'll catch you all in the next one. Take care.